So let's start off on inverse trig visually all 6 functions. So it's similar to things we've already done before, except now there's a visual element to it as well. So solve the equation cotangent of theta is equal to radical 3 for all values of theta in the domain 0 is less than or equal to theta, which is less than 2 pi. So pretty much solve cotangent theta is equal to radical 3 for anywhere in this unit circle in radians. Also, draw either a horizontal, vertical, or diagonal line that goes through all solutions to the equation. Express your answer both in radians and degrees. Okay, so I kind of hoped that they would give me a sine or cosine first, but they gave me a cotangent. That's okay. Let me screenshot this so I can write. Okay. Let me stop lagging before I keep going. I can see that I'm lagging. I apologize. I don't even know if it records me apologizing, but I still apologize. Okay. It's catching up. All right, so we are caught up now to my lag. Solve the equation of cotangent of theta is equal to radical 3. So let's remind ourselves what cotangent is. Cotangent of theta is equal to the cosine over sine, which translates to the x over y. Okay, so cotangent is the x over y. And then we know that in this case, it's radical 3. And so if we're going to turn this radical 3 into a fraction of x over y, then I'm going to make it a radical 3 over 1 because anything over 1 is itself. Now remember, on the unit circle, anything that is a fraction or anything that's shown, kind of is like over 2 if it's a fraction. So I'm going to make all of this over 2 over 2. Okay, so we have x on the top and a radical 3 over 2 on the top. So we want our x value to be radical 3 over 2 because that's what the top part of our fraction tells us. That's what it says over here, x being radical 3 over 2. And then if you look on the bottom part, we have, well, that's not the color I thought it would be. It's so dark. Okay, on the bottom part, we have y is equal to 1/2. So this is one spot on our unit circle where cotangent would be equal to radical 3. So we've done problems like this before. It's just that now there's going to be a visual element to it. So let me find the spot on the unit circle and just visually draw it out. We have x is radical 3 over 2 and y is 1/2. That is this point over here that is, you can't see it because I'm lagging, so give it a moment. I apologize. Man, I wish I recorded this yesterday. I'm so sorry. Okay, there you go. That blob that just appeared on my unit circle, that is the point where x is a radical 3 over 2 and the y is a 1/2. So far, do you have any questions? How did I put it under 2? So I put it under 2 because if you look at like everything that's on the unit circle, all of that stuff, you can see that if it has a radical 3 in it, it's always over 2. So I just converted everything to be over 2 in my fraction so that I can match it up onto the unit circle. Oops, there we go. So everything has to be over 2 on the unit circle, unless it's like one of the edge points over here. If it's not one of those four corners that I just pointed at, everything's over 2. So then on our fraction, when I have radical 3 over 1 and I want it to match it to the unit circle, I just put everything over 2. And that way we can match it. Okay, and then if you have any other questions, please interrupt me, but I'm going to keep going. So that giant blob that I put over there on the right unit circle, I am now putting it on the left unit circle. And so I'm going to write something. Should I write it now? Yeah, I'll write it now. So for cotangent, and if they give you a tangent, you're going to select the type of line, you're going to select a diagonal. So that means, like, you're just going to go straight through the origin and to the other side of the unit circle. This is another, okay, I lagged. Okay, so what I was trying to say was cotangent and tangent. You see where it says select the type of line over here? You want to select a diagonal line. And the reason for that is because cotangent and tangent, when you go all the way across, you're going to get the same numbers that you did on the other side of the unit circle. It's just that the signs will be flipped. And that's what we want, because if you have radical 3 over 2 divided by 1/2 equaling radical 3, if you have these divided equaling that, you can also have negative radical 3 over 2 divided by negative 1/2, and the negatives will cancel out, and you will still get the radical 3 that is the answer that they want us to find. So for cotangent and tangent, you want to select a diagonal line. I'll also write what you would select for a sine and a cosecant. So sine and cosecant relate to y values. You would select a horizontal line. And for cosine, secant, you would select a vertical line. Okay, so I suggest you write these 3. Oops, that was a really bad box. Write these things down. I'll give you guys some time. So cotangent and tangent, you would select a diagonal line. Sine and cosecant, a horizontal line. Cosine and secant, a vertical line. So since they gave us a cotangent, we're going to select the diagonal line. And hopefully in the next example, they'll give us a different thing, either a sine, cosecant, cosine, or secant, so I can show you why it's a horizontal or vertical line. Okay, but for now, we selected the 2 points where the angle measurement cotangent would give us a radical 3. We just need to provide our answer in radians now. So let me just circle the radian measures at those places and wait for my computer to not lag. And keep waiting for my computer to not lag. I know. I think I'm still lagging. Okay, can you hear me now? Okay, so I think you guys can hear me because it said my internet connection was unstable, which means I'm done lagging. So what I was trying to say was, we're going to give our answers in radians now. So for those 2 points that we selected, we have the radian of pi over 6 and 7 pi over 6. So our final answer is those 2 radians. So pi over 6 and 7 pi over 6. Okay, so I'm not quite sure where I was lagging. Any questions so that I can clarify specific parts? Yes, we're gonna do another one for sure. Okay, let's enter this in so that I can do another one then, I guess. So we have pi over 6, 7 pi over 6. And then, like I said, we're going to select a diagonal line, and then it already makes it go straight through the unit circle. We wanted it to go there, because those were the 2 points. Those yellow dots were the 2 points that we wanted. And then I scroll down, and oh, they want degrees too? It doesn't say degrees. Oh, express your answer in both radians and degrees. I see now. Okay, so let's do the radians first, because we said them first. It was the pi over 6. And the 7 pi over 6. And then now just to convert it to degrees, let me just screenshot it so I can point. For the pi over 6, we said it was 30 degrees. Oh my god, I'm lagging again. I'm so sorry, guys. I don't even know. Can you hear me when I'm apologizing for lagging? Okay, can you hear me now? A little bit. Oh man, okay. Okay, so we already said pi over 6 and 7 pi over 6. We just need to give the degrees now. You can see I circled over there. It says 30 degrees, and 7 pi over 6 is 210. So we're going to put 30 and 210. 30 to 10. Okay. Any questions on that part? Okay, let's do another one. I hope I don't lag. Please don't lag. Okay, next problem. Cool, we have a secant. Great. And they gave us a hard secant. How fun. We're going to lag while doing a hard problem. Okay, so secant is 1 over the cosine. So secant is the 1 over cosine, which is 1 over x. So we need to say 1 over x is equal to negative 2 radical 3 over 3. And when you have this crazy looking fraction over here, the best thing we can do is divide both the top and the bottom by radical 3. And so negative 2 divided by radical 3 is just negative 2. And 3 divided by radical 3 is radical 3. Remember, this is your 1 over x. Questions so far? Okay, if you do have a question, interrupt me, because I don't know how much I'm lagging. So maybe you have a question, but you just didn't hear me ask if you had a question for like 10 more seconds. Who knows? Okay, so we have 1 over x, but we want to know what the x is. So all you have to do is just like flip both of them. And so we have x is equal to, I'm just writing it here because that's where I have space, radical 3 over 2 negative. So all I did was flip it. So from here, a little flippy, and we get there. Any questions on that step? Okay, if at any point you have a question, just type it in the chat and I will get to it. I also want to just remind you of the things that I wrote earlier. So we said tangent slash cotangent was a diagonal. We said sine and cosecant were a horizontal. And then we said cosine slash secant were vertical. And so we're going to get into the why is it a vertical line that we're supposed to select over here? Why are we selecting a vertical? We're about to get into that. Okay, so let me zoom out. So if we have an x value of negative radical 3 over 2, let's find that on the unit circle first. And I see that over here because right there where I just pointed, the x value is negative radical 3 over 2. So the reason we draw a vertical line is we want to find anywhere else on this unit circle that also has a negative radical 3 over 2 as the x value. So if I draw a vertical line here, you can see that the point that I touched on the bottom right over here also has a negative radical 3 over 2 as the x value. So that vertical line helps you find the two spots on the unit circle where we have the x value as whatever it is that we wanted it to be. So we wanted a negative radical 3 over 2 as our x value. We found it in those two spots. So what we're going to do is just draw that same vertical line over here. Okay, any questions on that one? For that part, the vertical line part, or finding the x value? And then, yes, the video will be posted. Sorry, I didn't see that question earlier, but yes. Okay, so we're gonna do this vertical line, and we're also going to tell them which radians and which degrees. Let me just circle the radians and degrees now before I just type into delta math. Those are the answers that we want. The 5 pi over 6 and the 7 pi over 6 are our radian answers, and the 150 and the 210 are our degree answers. So let's type those in, or first draw our vertical line. Just drag the vertical line right over there. It will snap into place. And then we say for the degrees, it was 150 and or 210. And for the radians, it was 5 pi over 6. That's not 5 pi. 5 pi over 6, or 7 pi over 6. Okay, and then we can submit answer. All right, what time is it? 10:07. Wait, what? Oh yeah, okay. I forgot. Do you guys want to do one more, perhaps? I'm just gonna do one more, just in case. Okay, so we have a tangent. We have a tangent of negative radical 3. I'm gonna screenshot that. So we did already one that's pretty similar to this, but let's just do it again because I was lagging the first time. So tangent, remember, is the sine over cosine, also known as the y over x. So you want your y over x to be negative radical 3. So let's turn this into a fraction by putting it over 1. And once again, we don't have a radical 3 on our unit circle. We have radical 3 over 2. So we're going to just make both of them over 2 by dividing by 2 on the top and bottom. So you get negative radical 3 over 2 and 1/2 on the bottom. So then from here, we can say, oh, okay, our y should be the negative radical 3 over 2. So I'm going to write that here. Y can be negative radical 3 over 2. And then our x should be 1. Oops, sorry, not 1. 1/2. So I'll write that over here. X can equal 1/2. All right, and we're going to look for this on our unit circle. So let's look for negative radical 3 over 2 being the y, and positive 1/2 being the x. So that happens right over there. Okay. Any questions on that part so far? Okay. Remember, if you do, just type in the chat. And then for tangent and cotangent, we want to draw a diagonal line. like straight across. So I'm just going to draw my line straight across right here, right now. And you can see that this point is very similar to this point. The only difference is that the signs are flipped. And the reason that works for tangent and cotangent is because when you divide them, positive divided by negative is the same thing as negative divided by positive. You're still going to get the negative radical 3 as your tangent. So that point also works in our case. So we're going to have two answers. We're going to have the 2 pi over 3, aka 120 degrees, and the 5 pi over 3, aka 300 degrees. And we're going to represent this with a diagonal line. So before I go enter it into Delta Math, do you guys have any questions? Why is it diagonal? Okay, so when you have the points on the opposite side of the circle, notice that the x value is going to be like, it's still going to have a 1/2 in it, and the y value is still going to be a radical 3 over 2. The only difference is that the signs have flipped. So you had a positive 1/2 on the bottom, but you have a negative 1/2 on the top. You had a negative radical 3 over 2 on the bottom, but you have a positive radical 3 over 2 on the top. So any two points that are exactly opposite from each other on the diagonal line, they're going to have the same absolute value of the numbers, but the signs will be flipped. The reason that works for a tangent and the cotangent, because tangent slash cotangent are the diagonals. The reason that works for the tangent and cotangent is because you're doing, for tangent, it's y divided by x, and for cotangent, it's x divided by y. So just, it doesn't matter which one of these is negative or positive, as long as once you divide them, you'll still get the same number value over here. Like, for example, in our problem, we said that y should be, we said over here, trying to point. We said over here that y should be negative radical 3 over 2, and that x should be positive 1/2. When you divide this, negative radical 3 over 2 divided by 1/2, if you multiply the top and bottom by 2, you would get negative radical 3 over 1. And then you simplify that, you get negative radical 3, right? So that's one of our answers. The reason the opposite side works as well is, let me write it here underneath. We have on this opposite point, the y value is positive radical 3 over 2 divided by the x value is negative 1/2. So let's see, if we simplify this fraction, will it still give us the same answer? Then we're going to do the same steps, multiply by 2. And then you get radical 3 over negative 1. Simplify that, you get negative radical 3. So as you can see, oh, you cannot see because it's lagging. I'll repeat. Okay, so I was trying to say that if we just take the opposite point, which is over here, where the number values are the same, but the signs are flipped, let's divide it and see if we get the same thing. So we have the y value, positive radical 3 over 2 on the top, and the x value, the negative 1/2 on the bottom. You multiply them by 2 on top and bottom, you get radical 3 over negative 1. It says my internet connection is unstable, which means you didn't hear me say that. So when you divide it and you simplify it, you still get negative radical 3. So in both of our cases over here, I don't know what color to highlight it, negative radical 3 and negative radical 3 for those opposite side points. And that happens because when you have opposite side points, the only thing that changes is that the signs have flipped. But when you divide it, you're still going to get the same ratio in the end. Okay. I'm sorry, I had to repeat that so many times because of the lagging. Do you guys have other questions? I'm sorry. I'm sure you guys are frustrated. Okay, once again, if you have questions, just type it in the chat, but I'm going to enter in our answers, which are 120 and 300. So we attempt to select a diagonal line, drag it over there, and then now we list out our answers, 120 and 300, and then the other one is 2 pi over 3, and then the other one is 5 pi over 3, and then I quickly submit it before I start lagging again. All right, so that sums up our inverse trig visually all 6 functions section.